All right, let's talk about a technology that is completely changing the game for optical character recognition. And for any data engineer listening, this one's for you. We're looking at Tencent's HunyuanOCR, and specifically how it is finally killing the Frankenstein pipeline we've been stuck with for years.
Now, I can already hear you thinking, OCR? Come on, that's a solved problem. We've got open source tools, we've got cloud APIs. What more is there to even say about it? Well, if it's so solved, why does it feel like our data ingestion pipelines are held together with duct tape and prayers? You know the feeling, always just one blurry, folded invoice away from a total meltdown. The reality for most of us is still painful.
So here's how we're going to break it down. First, we're going to look at the monster itself, that Frankenstein pipeline. Then we'll see the revolution that kills it. We'll get into the secret sauce that makes it all work, look at the cold, hard numbers that prove it, and finally, show you how this is about to become your favorite new tool for RAG ingestion.
Okay, let's start by talking about the pain, the old way, the traditional OCR stack. If you've ever had to build one of these, and worse, maintain one, you know exactly what I'm talking about. For about a decade now, this is what OCR has looked like. It's this messy chain reaction. You'd use one tool for just detecting where the text is, like Tesseract. Then you'd pipe that to another model, maybe Paddle OCR, to actually recognize the characters. Then a third thing for layout, a fourth for named entity recognition, all before you even start writing code to clean up the garbage that comes out. It is literally a Frankenstein's monster of stitched together parts. And here's the killer. It's not just clunky. It's incredibly fragile. A tiny mistake at step one, like a shadow on a document confuses the text detector, that error doesn't just get passed down the line, it gets amplified. By the end, you have completely useless data, and you're stuck babysitting every single module in the chain. So, what if we could just get rid of all of that? What's the alternative to this rickety assembly line? Well, it's not an improvement, it's a revolution. It's about collapsing that entire pipeline into one single powerful step. And this is it. This is HunyuanOCR. Instead of that chain of 5 different services, it's one model, one end-to-end vision language model. You feed it an image, you give it a prompt, and you get clean, structured data back. That's it. One forward pass. The entire Frankenstein's monster. Gone. Okay, so you're probably thinking this must be some colossal city-sized model to pull this off, right? I mean, we're in an era where bigger is always better. But this is where the story gets really, really interesting. The entire model is just 1 billion parameters. Let me say that again, 1 billion. In a world of 100 billion plus parameter giants, that is tiny. This isn't a generalist trying to do everything. It's a highly trained specialist built for one job. And just look at this comparison. It puts it into perspective. You've got HunyuanOCR over here, and then you have a massive generalist vision model like Qwen, which is literally over 200 times larger. This is the difference between a surgical scalpel and a sledgehammer. So what does this tiny size actually mean for you, the engineer? It means you can run this with incredible speed on a single consumer GPU, like a 4090. In one case study, throughput jumped from a measly 180 pages an hour to over 1,100. All of that translates to way lower costs, way less maintenance, and never having to debug that fragile pipeline again. But wait, how on earth does a small 1B parameter model get so good at generating perfect, structured data? The magic isn't just in the size or the architecture, it's the secret sauce in how they trained it. They used a pretty brilliant technique called reinforcement learning with verifiable rewards. You can think of it like a really strict training program. It's not just about teaching the model to read text, it's about teaching it to obey the rules and respect the data format you ask for. The logic is actually dead simple. You ask the model for JSON. If it spits out anything that's malformed, a missing bracket, a broken schema, it gets punished, a reward of 0. It learns, through millions and millions of tries, that breaking the rules is not an option. And the results of all that strict training? You get a model that is an absolute expert on structure. It generates perfectly valid, schema-compliant output over 96% of the time. Think about that. That means no more writing endless validation scripts and regexes to clean up the model's mess. It just works. Okay, theory is great. Secret sauce is cool, but talk is cheap. Let's see the proof. How does our lean 1B parameter specialist actually perform against the massive general-purpose giants? So let's look at a complex document parsing benchmark.
You've got the heavyweights, Gemini 2.5 Pro, the monster 235B Quen model, and they're scoring in the high 80s. Then you have our little 1B model, HunyuanOCR, which comes in and scores over 94. It doesn't just compete, it crushes them.
And just to show you it's not a fluke, look at this. A really common task, pulling structured data out of receipts. The big models are hovering around 80% accuracy. HunyuanOCR, over 92%. That's a 12 to 14 point lead. That's not an improvement, that is a beatdown. The specialist wins.
So all of this brings us to the most important question. What does this mean for your work right now? And if you're building any kind of retrieval augmented generation, or RAG, system, listen up.
The big takeaway here is really simple. You can finally stop paying for expensive, slow, rate-limited OCR APIs. You can take that critical first step of any RAG pipeline, getting your documents into a clean, usable format, and bring it completely in-house. This is, hands down, the ultimate RAG ingestion engine. You can now take all those messy PDFs, all those scanned documents, and turn them into perfect Markdown or JSON right on your own hardware. That means you're feeding pristine, structured data straight into your vector database. And you can do it at scale, avoiding all the cost, the latency, and the privacy concerns of sending your data to a third-party API. And that leaves us with one last big idea. When the task is critical, when structure matters, and when efficiency is key, it turns out a small, hyper-focused specialist can absolutely run circles around a massive generalist. Maybe the future isn't just about building bigger models. Maybe the era of the small, efficient specialist is just getting started.